theta. Now let's take the partial with respect to theta. The partial of this with respect to theta is negative r sine of theta. Negative r sine of theta. The partial of this with respect to theta is r cosine theta. R cosine theta. And the partial here, this is 0, and then this would be negative r sine theta. Negative r, oh no, let me be careful. This is going to be, you have a negative r, so the derivative of cosine theta with respect to theta is negative sine theta. So the negatives are going to cancel out, and so you're going to have r sine theta. And now we can actually evaluate this determinant to figure out the cross product of the partial of this with respect to r and the partial of this with respect to theta. I'm not writing it down just to kind of save some real estate here. And so we have, actually maybe I will write it down just to be clear what we're doing. The partial of S3 with respect to r crossed with the partial of S3 with respect to theta is equal to, now our I component is going to be sine theta times r sine theta. So that's going to be r sine squared theta minus r cosine theta times negative cosine theta. So that's plus r cosine squared theta. All of that times I, and you already, a simplification might be popping out here at you. And then you have minus the j component. The j component is going to be cosine theta times r sine theta. So it's r cosine theta sine theta. And then we're going to subtract from that. See, the negative signs cancel out. So you're going to subtract r sine theta cosine theta, or r cosine theta sine theta. Well, this is interesting because these are the negatives of each other. R cosine theta sine theta minus r cosine theta sine theta. This just evaluates to 0. So we have no j component. And then finally, for our k component, we have cosine theta times r cosine theta. So we have r cosine squared theta minus r sine theta times sine theta. So, or minus negative r sine theta times sine theta. So this would give you a negative, but we're going to have to subtract it, so it gives you a positive. So plus r sine squared theta k. And so this simplifies quite nicely, because this is going to be equal to, this term up here, you can factor out an r. This is r times sine squared theta plus cosine squared theta, which is just, that part simplifies to 1. So that's just r times I. So this is equal to r times I. And we do the same thing over here. This also simplifies. This is actually the same thing. This also simplifies to r. So this whole thing simplifies. Let me write it this way. This is also r sine squared theta plus cosine squared theta, also simplifies to r. So you have r times k. And so if you want the magnitude of this business, so let me make it clear. So the magnitude, we'll go back to the magenta. The magnitude of, I don't feel like rewriting it all. I'll just copy and paste it. Edit, copy, and paste. The magnitude of all of this business is going to be equal to the square root of this squared, which is r squared, plus this squared, which is r squared, which simplifies to, this is 2r squared. So you take the square root of both of those, you get the square root of 2 times r. So this is equal to the square root of 2 times, it would be the absolute value of r, but we know that r only takes on positive values. R only takes on positive values, so it's the square root of 2 times r, which is very nice because now we can evaluate ds. ds is going to be this business times dr d theta. So let's do it. So our surface integral, the thing that we were dealing with from the beginning, that thing right over there. So our surface integral, the surface S3 of z ds is now equal to, so I'm going to use different colors for the different variables of integration. So one on the outside, and then I'll do one on the inside. I'll do the inside one in pink. Z is equal to 1 minus r cosine theta. So z is equal to 1 minus r cosine theta. It involves both, so I'll use a different color. Minus r cosine theta. And then I just have to integrate relative to both of the variables. 1 minus r cosine theta. Oh, no, I have to do the times ds. ds is this thing. It's this thing times d theta. dr. So let's see, let's write this down. Times square root of 2r. So let's write that down. So this times the square root of 2r times the square root of 2. And we can write the square root of 2 out front since it's a constant. So let me just do that. Simplify things. Square root of 2 times r. And now d theta dr. Or we could write dr d theta. Either way. So let's do that. Let's do dr d theta. So dr d theta. We could do it either way. It's going to be about the same level of complexity. And so first we're going to integrate with respect to r. And let me do the colors the same way, actually. So dr d theta. d theta. If I've got colors, I might as well use them. And actually, I just realized that I'm way out of time. So actually, let me continue this in the next video. We'll set up the boundaries of integration and then just evaluate it.